Assalamualaikum warahmatullahi wabarakatuh, and welcome to our presentation. Today we're gonna talk about transition metallurgy of iron. Before we start our presentation, I would like to introduce our group member. First, one of our Anis. Then, I am Muhammad Hanafi, Nur Nabila Izzati, Muhammad Isnur Rizal. Lastly is Alia Hana. So let's begin this presentation with introduction. Iron is naturally found in the earth mainly as oxide, carbonate and sulfates. The most common iron ores include hematite, magnetite and iron pyrite, all of which contain impurities. To extract iron metal, these ores are heated with carbon, typically coke, which reduce the iron compounds into usable iron during the metallurgical process. So next is objective. So the first objective is to explain the concept of metallurgy in relation to iron extraction. Second, to identify the main ores of iron found in nature. Third, to describe the steps involved in the metallurgy of iron. Fourth, to explain the reaction occurring in the blast furnace. Lastly, to distinguish between the commercial forms of iron.
Now we moving on to discussion.
Ores of iron. Iron is found in nature in form of its oxide, carbonate, and sulfate. Iron's ore contain impurities. Iron's ore is reduced to iron metal by heating with carbon, coke. The main ores is hematite, magnetite, and also the last one is iron pyrites.
Here we provide a video explaining the differences between hematite and magnetite to help you understand them better.
From an academic perspective, it is important to know what is inside of iron. Iron ore is most often found in the form of hematite and magnetite ores. In this video, we will learn what makes them different. Iron is a ferrous metal, or you can also say ferrous metals are those which contain iron. The ores are usually rich in iron oxides. Iron is usually found in the form of magnetite, hematite, goethite, limonite or siderite. These two ores are the most talked about. Ores containing very high quantities of hematite or magnetite are known as natural ore or direct shipping ore, which means they are of high export quality. These two ores can be fed directly into blast furnace for making iron. Magnetite is the finest iron ore with a very high content of iron, up to 70%. It has excellent magnetic qualities, so you can easily correlate magnetite, magnetic. Now this quality helps in getting separated from the rocks during its extraction process. The color of magnetite ranges from dark grey to black. Magnetite is derived from the Greek word for blood, and the color ranges from red to reddish brown. It does have more iron content, but not more than magnetite. However, it sometimes occurs in high-grade deposits. It has a weak magnetic property.
We hope this helped you better understand the differences between hematite and magnetite. Now, let's proceed to the next slide.
The first one is concentration. The one is crushes in crushers and is broken to small pieces. Is it concentrated with gravity separation process, in which is it washes with water to remove clay, sand, and so on. The second one is calcination. The ore is then heated in absence of air. The third one is melting. The concentrated is mixed with calculated quantity of coke, limestone, and the mixture is put in the blast furnace from top.
This slide shows the structure of a blast furnace used in the extraction of iron. Iron ore, coke and limestone are added from the top of the furnace. Hot air is blown in from the bottom, causing the temperature to rise to about 1500 degrees Celsius. At this high temperature, iron ore is reduced to molten iron, which collect at the bottom of the furnace. The impurities form molten slag, which float above the iron. Finally, waste gases escape from the top of the furnace. Next, I will talk about metallurgy of iron. First is the formation of carbon monoxide. Coke burns in air to produce carbon dioxide and a large amount of heat. This heat increases the temperature inside the blast furnace. The carbon dioxide formed then reacts with more coke to produce carbon monoxide, which is an important reducing agent. Next is the reduction of iron ores to iron. Carbon monoxide reduces iron oxide into molten iron. For example, hematite is reduced to iron and carbon dioxide. Magnetite also undergoes a similar reduction reaction. The molten iron produced is collected at the bottom of the furnace.
The function of limestone are: first, acts as floods to remove sand from hematite in form of liquid slag. Second, limestone decomposes to produce calcium oxide CaO and CO2. Third, this CaO reacts with silica sand present in the ore to form slag CaSiO3.
Now moving on to the final part, which is our general conclusion. In summary, the metallurgy of iron is a precise multi-stage process, evolving from initial concentration and calcination to the high temperature smelting within a blast furnace. By utilizing coke and limestone as essential agents, we can effectively extract molten iron from its ore. The final versatility of this metal is realized through its refinement into cast iron, rough iron, and steel. Each of these iron manufactured with specific property to meet the demand of modern industries. So, all of these are our references that we use in our video presentation. That's all from us in explaining our topic, which is metallurgy of iron. Thank you.